All right, so our next section is dealing with rational numbers. Um, we're covering everything that includes rational numbers, so before we even get into it, I wanted to refresh your memory on what rational numbers are. So first of all, I put our drawing that we talked about earlier in the year. We have whole numbers. Remember, whole numbers start at 0 and they go up on the number line. So 1, 2, 3, 4, 5, 6, okay, goes on and on forever. Integers include all the whole numbers. So it includes 0, it includes 1, it includes 2 and 3, and on and on and on. But it also includes the negative numbers. So -1, -2, again, on and on and on, all the way down the number line. So integers are basically everything that you would see on the number line, okay? All those positive numbers, negative numbers, and 0. Rational numbers include all of those. -2, -1, 0, 1, 2, on and on in both directions. All of those are rational numbers, but it also includes fractions such as 1/2, 2/3. It also includes decimals like 4.5, -2.3, -1.6 repeated. Okay, all those would be rational numbers. The only difference, the only other kind of numbers that we deal with in 8th grade are called irrational. So most of the time you are dealing with rational numbers. Just so you know though, irrational numbers would be decimals that don't end or don't repeat. So like pi is an example of an irrational number because it's 3.1415, on and on and on. It never ends, it never repeats, it's irrational. Another irrational would be something like -2.17425. Okay, it goes on and on and on. It never repeats, it never ends. So we're not looking at irrational today. I just wanted you to understand the difference though from rational and irrational. All right, so first of all, with our rational numbers, we want to find 3 fractions that are equivalent to 1/3. So remember, like we talked about in the last lesson, as long as you multiply or divide by the same number in the numerator and the denominator, it's going to be equivalent. Okay, so if I have 1/3, if I want to find the equivalent fraction, now we could all have different answers, but what I chose to do was to multiply by 2. As long as I do the same thing in the numerator and denominator, it's going to be equivalent. You can multiply by any number that you want, but I just chose 2. So that would equal 2/6. That means that 2/6 is equivalent to 1/3. Okay, let's find another fraction that's equivalent. Remember, it's not asking us to simplify now, it's just saying equivalent fractions. So I took 1/3 again. Again, you can multiply by any number that you want. I chose to multiply by 3. So when you multiply 1/3 by 3 in the numerator and the denominator, you get 3/9. Obviously, it's not simplest form, it's just equivalent to 1/3. And then for my last one, that's only 2 fractions. They asked me to find 3. I chose, again, you could choose any number you want. I chose to multiply by 100 in the numerator and the denominator, which would equal 100 over 300. So 3 equivalent fractions to 1/3 would be 2/6, 3/9, and 100 over 300. There's an infinite amount. There are so many more. It's just that those are the 3 that I chose. So we could all have different answers and we could still be correct. I want you to understand that. All right, let's take a look at the next example. Now they want us to graph each rational number on a number line. So first of all, let's just look at the number line. We've got 0 in the middle, we've got -1/2, then -1, we've got +1/2 and +1. Now, just in case you're not familiar with this, I want everybody to understand, I wrote it underneath here, that -1/2 is the same as -0.5. And +1/2 is the same as +0.5. Okay? A lot of people tend to deal with decimals a lot easier than fractions. So what I recommend is that you convert your fractions to decimals. So first let's graph -8/10. Okay, so in order to convert this, here's my calculator. I'm going to take -8. Remember, I'm just changing a fraction to a decimal. So I'm dividing by 10. Numerator divided by the denominator, and we get, in case you can't see that, it says negative 0.8. Okay, negative 0.2 is already a decimal. Let's change 4/10 to a decimal. Let me get my calculator again. Clear that out. Now we have 4 in the numerator and we are dividing by 10. That's 0.4. And then 0.9 is already a decimal. All right, so first let's graph negative 8/10. Just so that you see this, if this is 0 and this is negative 0.5 and then this is negative 1, each of these would be moving over 1/10. So this would be negative 0.1, negative 0.2, negative 0.3, negative 0.4, and then we get to negative 0.5, and then we keep going. Negative 0.6, negative 0.7, negative 0.8, negative 0.9, and then negative 1. All right, so therefore, negative 8/10 would be, this was negative 0.5, this was negative 0.6, negative 0.7, negative 0.8, so that would be right here between the negative 1/2 and the negative 1. Does it need to be exact? No. But you need to be close to that spot. So that was right, it was a little bit closer to the negative 1. Right there would be negative 8/10. Okay, now negative 0.2. Remember we just said, well, this is negative 0.1, this was negative 0.2, so that would be approximately right there. And now let's do the positive ones. 0.4, well, if this is 0.5, 0.4 would be right in front of it, but I need to space it out a little because remember this would be 0.1, 0.2, 0.3, so this is about 0.4. And then my last one, 0.9, would be right in front of the positive 1, 0.9. So those are those numbers on a number line. All right, moving on to the next thing. Evaluate. We've done a lot of this. You're solving. So it says evaluate negative 2y over x squared for x equals 9 and y equals 3. So remember when you do this, you're just plugging in place of the x, you're going to put a 9, and in place of the y, you're going to put a 3. I still see people doing negative 23. It's not negative 23. Remember when you have a number next to a variable, it means multiply. So this is negative 2 times y. So when you plug in the 3, it's negative 2 times 3, which is what I wrote right here. So I plugged in the 3 in place of the y and the 9 in place of the x. So then when we solve that, we just want to multiply in the numerator, which would be negative 2 times 3 is negative 6, and then 9 squared in the denominator would be 81. So we have negative 6 over 81. However, that is not simplest form, and you never want to leave an answer that's not simplified on a test unless it specifically says do not simplify. So I need to find a common factor for both of these. You can use your calculator, whatever you need to do, but I'm going to look at the factors of negative 6 because that'll be a lot easier than coming up with all the factors for 81. So the factors of negative 6, let's just do 6 for now. So the factors would be 1 times 6 and 2 times 3. That's it. So I want to try, okay, is 81 divisible by 6? Let's try that one first. Let's see, 81 divided by 6 is a decimal, so no. Let's try 81 divided by 3. Okay, that one works. We get 27. So therefore I could divide both the numerator and the denominator by 3. 6 didn't work. And when we divide both of those by 3, we get negative 2 over 27. That would be simplest form. All right, that's it for today, guys. Bye-bye.